Hello, everybody, again. So, today we're going to learn Chapter 10 about straight lines and quadratic equations. Let's start. Key words: equations of a line, gradient, y-intercept, constant, x-intercept, line segment, midpoint, expand, constant term, quadratic expression, factorization, difference between two squares, quadratic equation. In this chapter, you will learn how to construct a table of values and plot points to draw graphs, find the gradient of a straight line graph, recognize and determine the equation of a line, determine the equation of a line parallel to a given line, calculate the gradient of a line using coordinates of points on the line, find the gradient of parallel and perpendicular lines, find the length of a line segment and the coordinates of its midpoint, expand products of algebraic expressions, factorize quadratic expressions, solve quadratic equations by factorizations. So, Jeff wishes he had paid more attention when his teacher talked about negative and positive gradients and rates of change. On 4 October 1957, the first artificial satellite, Sputnik, was launched. The satellite orbited the Earth, but many satellites that do experiments to study the upper atmosphere fly on short, suborbital flights. The flight path can be described with a quadratic equation, so scientists know where the rocket will be when it deploys its parachute, and so they know where to recover the instruments. The same equation can be used to describe any thrown projectile, including a baseball. Recap. You should already be familiar with the following algebra and graph work. A table of value and straight line graphs from Stage 9 Mathematics. A table of values gives a set of ordered pairs that you can use to plot graphs on a coordinate grid. -1, 3, 0, 4, 1, 5, and 2, 6 are all points on the graph. Plot them and draw a line through them. Equations in the form of y equals mx plus c from Year 9 Mathematics. The standard equation for a straight line graph is y equals mx plus c. M is the gradient or steepness of the graph, and c is the point where the graph crosses the y-axis, or the y-intercept. Gradient of a straight line, Year 9 Mathematics. The gradient m is the rise over run, which is the change in y values over the change in x values. Drawing a straight line graph, Year 9 Mathematics. You can use the equation of a graph to find the gradient and y-intercept and use these to draw the graph. For example, y equals a third x minus 2. The gradient is 1 up and 3 right, and the y-intercept is -2. Expand expressions to remove brackets from Chapter 2. To expand 3x open bracket 2x minus 4 close bracket, you multiply the term outside the bracket by each term inside the first bracket. So 3x open bracket 2x minus 4 close bracket is 3x times 2x minus 3x times 4, which is 6x squared minus 12x. Lesson 10.1. Straight lines. Using equations to plot lines. Mr. Keeley owns a boat hire company. If Mr. Keeley makes a flat charge of $40 and then another $15 per hour of hire, you can find the formula for the total cost $y after a hire time of x hours. Total cost is the flat charge plus the total charge for all hours, or y equals 40 plus 15 times x, or rearranging y equals 15x plus 40. Now, think about the total cost for a range of different hire times. 1 hour, it costs 15 times 1 plus 40, which is $55. 2 hours, which costs 15 times 2 plus 40 is $70. 3 hours, which costs 15 times 3 plus 40, which is $85, and so on. If you put these values into a table with some more added, you can then plot a graph of the total cost against the number of hire hours. The graph shows the total cost of the boat hire, plotted on the vertical axis, against the number of hire hours on the horizontal axis. Notice that the points all lie on a straight line. The formula y equals 15x plus 40 tells you how the y coordinates of all points on the line are related to the x coordinates. This formula is called an equation of the line. The following worked examples show you how some more lines can be drawn from given equations. Worked example 1. A straight line has equation y equals 2x plus 3. Construct a table of values for x and y and draw the line on a label pair of axes. Use integer values from x from -3 to 2. Substituting the values -3, -2, -1, 0, 1, and 2 into the equation gives the values in the following table. Notice that the y values range from -3 to 7, so your y-axis should allow for this. So here's a graph of y equals 2x plus 3. Work example 2. Draw the line with equation y equals -x plus 3 for x values between -2 and 5 inclusive. The table for this line would be this. So here is a graph of y equals -x plus 3. To draw a graph from an equation, draw up a table of values and fill in the x and y coordinates of at least 3 points, although you may be given more. Draw up and label your set of axes for the range of y values you have worked out. Plot each point on the number plane and draw a straight line to join the points using a ruler. Exercise 10.1. Make a table for x values from -3 to 3 for each of the following equations. Plot the coordinates on separate pairs of axes and draw the lines. So on the top, there are the coordinates, and on the bottom, here are the axes and the line. Again, on the top here are the coordinates, and on the bottom here is the graph of the line. So here on the top here are the coordinates again, and on the bottom here is the line. On the top, here are the coordinates again, and on the bottom, here is the new line. The coordinates are at the top, and the line is at the bottom. On the top, there are the coordinates, and on the bottom, here is the line. Here, the coordinates are at the top again, and at the bottom, here is the line. So the coordinates are at the top here, as you can see, and at the bottom here is the graph of the line. Okay, this is getting repetitive. At the top, here are the coordinates, and at the bottom, here's the graph of the line. At the top, here are the coordinates, and at the bottom, here is the line. So here it's the same thing for the last ones. Again, here's the same thing for the last ones. Again, here at the top, there are the coordinates, and at the bottom, here is the line. At the top again, here are the coordinates, and at the bottom, here is the line. Well, the coordinates are at the top again, and the line is at the bottom. Here, it's just the same thing. The coordinates at the top, and the line at the bottom. Question 2. Plot the lines y equals 2x, y equals 2x plus 1, y equals 2x minus 3, and y equals 2x plus 2 on the same pair of axes. Use values from -3 to 3. What do you notice about the lines that you have drawn? So here are the 4 lines, and the thing about the 4 lines that are the same is that they are all parallel. For each of the following equations, draw up a table of x values for -3, 0, and 3. Complete the table of values and plot the graphs on the same set of axes. Here are the coordinates, and here are the lines, as you can see here. Use the graphs from question 3 to answer these questions. Where do the graphs cut the x-axis? Which graphs slope up to the right? Which graphs slope down to the right? Which graphs cut the y-axis at 0, 2? Which graphs cut the y-axis at 0, -2? Does the point 3, 3 lie on any of the graphs? If so, which? Compare the equations of graphs that are parallel to each other. How are they similar? How are they different? So, the thing is, y equals x plus 2 cuts the x-axis at x equals -2. Y equals -x plus 2 cuts the x-axis at x equals 2. Y equals x minus 2 cuts the x-axis at x equals 2. And y equals -x minus 2 cuts the x-axis at x equals -2. Y equals x plus 2 and y equals x minus 2. -x plus 2 and -x minus 2. Y equals x plus 2 and y equals -x plus 2. Y equals x plus 2 and y equals -x plus 2. None of the graphs. Y equals x plus 2 is parallel to y equals x minus 2. Y equals -x plus 2 is parallel to y equals -x minus 2. For h, it is the same coefficients of x, but different constant values. So, that's the end of this video. Thank you and goodbye!